made astronomers observed Mercury to see how well it matched up, only it did not. The Verrier tried again, reasoning that it was possible. His maths have been out. He did a much more thorough study in 1818, using multiple observed sightings of Mercury as his baseline. He once again mapped out Mercury's orbit, but once again his predictions were out, not by much, only 45 arcseconds per century, but enough that there was conclusively something weird going on. Confident of his maths, this time Leverrier reached the conclusion that there must be some mass pulling Mercury out from the idealized orbit, either a planet or a series of asteroids given his success. By now, at locating Neptune, many astronomers believed him. Scientists rushed to telescopes to try and spot the alleged planet, and it wasn't long before results began to come in. Spotting a planet so close to the Sun was inherently difficult. The glare of the Sun would completely obliterate the reflected shine of a tiny planet. As such, the most effective method of spotting such an object was to see the darkening it caused as it traveled across the Sun. And in 1859, Edmond Modeste Lirol claimed to have seen just that. Lissard was a French amateur astronomer and physician who, using basic tools in a homemade observatory, claimed to have spotted a small black object passing by the Sun. On the 22nd of December, he wrote to Leverrier, who was so taken by his claim that he traveled by train to the man's home unannounced to verify it. He questioned. Le Carral heard his observations and came to the conclusion that the man was telling the truth. So the two of them announced the scientific community Le Carral's discovery. They named the planet Vulcan. The scientific community was once again very impressed. Les Carrel was given the Léon d'Or on the highest order of merit in France. He got to speak at meetings of learned scholars. There was only one problem. The planet he had discovered didn't actually exist. There were numerous proofs of this, for one naturally. Other scientists wanted to take a look at this new planet Vulcan. The Verrier calculated from Les Carral's observations that Vulcan must orbit 21 million kilometers out from the Sun, and did so every 19 days and 17 hours, so it would be easy to spot as it would be calculable when it would pass the Sun. Again, next, astronomers pointed their telescopes towards the Sun at the appointed time, but Vulcan was a no-show. Verrier was troubled by this, but by then more reports were coming in of the planet sighting. Other astronomers were going back through their records and were matching up phenomena they had seen with the new planet Vulcan. Some of these were years out of date and not even listed as to when in the year they had happened, but Leverrier still used these to tinker with his model, reasoning that perhaps his maths were just out. So he would predict and would not see Vulcan, and would rework his theory and would not see it again. Another piece of damning proof came from Emmanuel Lyre, another French astronomer. Le claimed that he had been coincidental looking at the Sun at the exact moment Les Carrel had, with a twice as powerful telescope, and had not seen the planet. Les Carrel had claimed to have observed Vulcan's existence floated through murky waters, as there were renowned scientists who did claim to see it from time to time. Leverrier died in 1877. But just a year later, in 1878, two well-renowned astronomers both claimed to have seen Vulcan at the same point in the sky. At the same time during a solar eclipse, they even both claimed that the planet was reddish in color. The cooperation was compelling. Yet Vulcans still did not exist in science. If a fact is true, then it is repeatable. And in spite of all these observations throughout the years, Vulcan was never repeatedly observed. It was never seen during a solar eclipse that again, in time, that corroborated sighting was put down to calculation errors and misidentifying a known star. But ultimately, the one who finally put the idea of Vulcan to rest was Albert Einstein. And he did so by thinking of something completely different. Numerous scientists over the years had attempted to see Leverrier's planet Vulcan, because mathematically they were certain it had to exist. Newtonian physics demanded that it did. They strained to see it. And in that confirmation bias, they did see it again and again, just never in the same place. But Einstein realized that it was Newtonian physics that was at fault. In 1915, he proposed a model of physics that accurately described the motion of the universe, but relied on things like curvature of space-time, rather than gravity. At slow speeds, it looked a lot like Newtonian physics, but when you placed objects like Mercury next to very massive objects like the Sun, special relativity predicted a different path for their orbits. And sure enough, Einstein's model predicted the exact orbit that Mercury made around the Sun, deviations and all. And with that, the case for Vulcan's existence evaporated under special relativity. It couldn't exist. There could be no object next to the Sun of a planetary size, or it would mess with Mercury's orbit so that it would no longer line up with the maths. And this time, Einstein was able to prove his maths correct through tests like the Eddington experiment. There is a lesson in this somewhere. Sometimes, if we want something too much, we find it, regardless of whether it is really there or not. Sometimes it takes thinking outside the box and challenging our previously held beliefs before the truth can be found out. As scientists, and equally as lay people, it's important that we do not hold too tightly to our ideas. The truth does not need our fervor. It will prove itself given time and opportunities for repetition. So there.